dynamic, and prior to that worked in a gas distributor in the UK, SGN. And I've built up some expertise around heat pumps and how to deploy them quickly. And so the purpose of my short presentation today is to just give a flavour of the importance of heat pumps, and also to end up with some practical tips and points for local authorities. And in my presentation, there are also some images, and there are some examples and some documents that might help. So hopefully you can see me okay. It's difficult to know what you can see, but I think if I press this button, you might be able to see me better. Does that look okay to everyone? If I can get a thumbs up in the chat, that would be great.
Looks good.
Okay, wonderful. So I can move my screen now. There we go. So just to start international, then zoom in. This is from the International Energy Agency's net zero scenario, which came out, I think, last year. And basically this looked at what the cost-effective pathway was for buildings around the world. So this is every single building around the world in a cost-effective net zero pathway. And basically, it shows two things. So it shows that building numbers increase, so the floor area increases, but the overall energy demand can be reduced with energy efficiency. That's the left-hand side. But the right-hand side is the important one for this presentation. So what that shows is the current heating mix on the left. So if you can see my cursor, I've got lots of coal and oil at the bottom, lots of gas. So gas is in the lead in terms of global heating, and a small amount of district heating and a small amount of heat pumps. But basically, to reach the climate targets, the net zero targets at a global level, you need to get to 2050. And in 2050, the global heat mix is dominated by heat pumps. So this big blue box there is the chunk of heat that comes from heat pumps. So in 2050, over half of the world's heating coming from heat pumps, a big chunk also from solar thermal, but that's geographically quite specific, and also a role for heat networks. So these are systems whereby heat is distributed via pipes rather than through, via water in pipes or steam in pipes, rather than through electricity wires or gas pipes. So there aren't many of these global analyses that have been done. However, McKinsey, the global consultancy, also did another one, and this is their take on the global net zero scenario, the best option for heat decarbonisation, so based on the cheapest option primarily. Similarly, and this is heating systems at the top and cooking systems at the bottom. And what you can see is that fossil fuel is squeezed out, the dark bit is squeezed out. And then by 2050, the heat mix is made up almost entirely of, or the number of heating systems is made up entirely of heat pumps or people connected to heat networks. And actually in their scenario, heat pumps at a building level were even more important than connections to heat networks. But across both of those big studies, big global energy system studies, the building focus showed a very important role for heat pumps and heat networks. So some of you, apologies if I'm teaching you all to suck eggs. Just quickly, how does a heat pump work and why are they important? Well, a ground source heat pump works using a network of pipes. So it takes pipes across a large surface area and it extracts heat from the ground. An air source heat pump extracts heat from the air. So rather than having a network of pipes, it's got a very small network of pipes in there, a heat exchanger, and a fan sucks in air and it blows the warmish air over the heat exchanger and pulls the heat out of it. You can also extract heat from sewers, from other waste systems, from deeper to get hotter temperatures, from lakes, from the sea. All of these things have heat in them and it's extractable. But one of the key, or if not the most important component in the heat pump is the compressor. This is one down there. You may have seen one of these before. You might have one in your air conditioning in your car. There'll be one in your fridge. And what the compressor does is it takes the warmish vapor liquid mix, which is called the refrigerant. So there's a fluid circulating in here. It takes the heat from that, which is warmish, but not very hot. And basically it squeezes all of the heat together. And it ends up being at a higher temperature than the heat that went into it. So you might get maybe 10 degrees coming out of the ground or 15 degrees coming out of the air, and the compressor effectively takes all of that, which is the gas, and squeezes it together, and you end up with a much higher temperature. And that's how you end up with the temperatures that you can use to charge a hot water cylinder, or to put through radiators, or to put put through underfloor heating. The technology is very, very similar to that currently used in refrigerators and air conditioners. Oh, sorry, just to go back, actually, it's also worth noting that there are two reasons why they seem to be very, very important. One is because there are more than two, but the two key ones is one is that they can be powered by electricity, and they tend to be powered by electricity, and electricity is getting increasingly low carbon, and the costs of renewables have plummeted. And the second fact is that the heat pumps extract most of the useful heat that they produce from these environmental sources. And that heat is inexhaustible, it's renewable, and it's low carbon. And so you get those two huge benefits. It's very efficient because you're getting much of the heat from the environment, but also it's very low carbon because you can supply them with low carbon electricity. So looking at the UK forecast, so I showed you the global ones, and this is analysis that's behind the work done by the Climate Change Committee at a national level in the UK. And this is basically an extract or two extracts from their balanced pathway. In that pathway, and balanced, by balanced they mean the most technologically sensible and pragmatic and the most cost effective. So some judgments have been made. There are pathways with higher levels of electrification and with higher levels of gas, but this is what they see as the most pragmatic pathway. And you can see again in this, sorry, another bar chart, but a bar chart for 2050, in their idealized cost-effective scenario, there is a big chunk at the bottom, and this is all of the homes, so 28.3 million homes in the UK. Around 11 million of them end up with air source heat pumps, 5 million with ground source heat pumps, and 5.5 million connected to heat networks. And all of the other buildings have some sort of heat pump too, pretty much, bar a few. For example, there might be some which have storage heaters or resistive heating, which is just the same as a kettle. But even this big chunk here is heat pumps, but backed up with hybrid type systems. So that could be an electric resistive system or potentially a hydrogen network, a hydrogen boiler, if that ever comes to be. But fundamentally, nearly all of these homes are connected to heat networks. And even when we look at the district heating networks, this chunk here, they also expect a lot of that heat to be coming from large heat pumps. So, for example, those attached to waterways like Bristol City Council is doing. And then when we look at this at a building level, you can see the expected growth in heat pump to meet the net zero target under the balanced pathway. And this is building level heat pumps. And you can see it growing to a huge number very rapidly, particularly in the 2030s is where the steepest growth is, but it continues to the 2040s. By 2050, when around 28 million homes do have heat pumps. Under this pathway, which reflects the previous IEA, the International Energy Agency pathway, and the McKinsey pathway, building level heat pumps are expected to dominate. So for local authorities then, what to do? Well, there are two sides to this, of course. There's the district heating side, and then there's the heat pump side. You need to find out what goes where first. That's a priority. So one example, again, I've talked about Bristol already. Bristol has done its heat mapping, it's worked out where the highest heat loads are, and it's now developed an area for priority heat network access. And so buildings in this area are expected to contact Bristol City Council to ask for connection details, because Bristol is laying the main around here and it will be expanded over time. They have a large agreement with Ameresco and Vattenfall to run much of this project for them. And so they've suggested that this area will become heat networks. And now everywhere else, because you can't burn any fossil fuels and the options are limited, it's all of these areas where it's expected to be heat pumps. So this is sort of the first step. Help is available through the local area energy planning, which the Energy System Catapult runs and has run for a number of local authorities. And that can effectively spit out something like one of these maps, but in much more granular detail and with advice about how to deliver some of these things. So that sort of covers the first bit. When it comes to actually deploying heat pumps, what will local authorities need to do? Well, primarily it's the public estate that's the issue. So because there are only limited interventions that local authorities can make into private dwellings. So social housing is likely to be a real priority. how is social housing decarbonised, and how are heat pumps installed in social housing, and also how is the public estate decarbonised. And I think Dan's going to talk about some of that afterwards. It's worth saying that I've dealt with the National Housing and Maintenance Forum quite a lot, who many of you may deal with, and they are quite up to speed on these issues. And their framing was interesting when I spoke to them in February, and they said this is much easier and much less money than the Decent Homes standard. So there is some optimism there and some experience too. In terms of the preparation of buildings, an important thing is the public estate up to it for heat pumps? Is it efficient enough? And most buildings, if not all buildings, can be heated with heat pumps, and there is a balance. But it's important to recognise that there's probably a lot of cost-effective energy efficiency measures that are still going to be needed in any scenario. Although I would just say there's a live conversation going on about exactly what the level of energy efficiency needed is for optimum heat pump deployment. And if you're interested in that particular issue, there's some reading there from a consultant that did work for UK BEIS that basically said with the development of higher temperature, higher performance heat pumps, some of the deeper retrofit work, solid wall insulation in particular, may no longer be necessary on a sort of household cost basis because you can actually get good performance without lots of efficiency. However, what that work didn't take into account was the energy efficiency impacts of the wider energy system. For example, what is the knock-on to the power grid and what is the knock-on to the electricity system in terms of generators and power stations. And the final big consideration for local authorities will be, how do these heat pumps go in? Are they single dwelling systems? So does each flat or each house have its own heat pump? Or do you put in a shared system where you share pipes and have one big heat pump, whether that's in an estate or in a block of flats? That might make more sense. Worth pointing out that these shared systems are actually very similar to district heat networks, just at a different scale. So in terms of the practical installation issues, I guess there are three big ones as a household or as a household manager you might be interested in. You need space to put the external unit for air source heat pumps. For ground source heat pumps, the boreholes or the slinkies are hidden, whereas for air source heat pumps, you need to have one of these units, which looks very much like an air conditioning unit. It basically is, but the components are put in backwards order. These can be freestanding, they can go on the side of buildings, they can be hidden at the end of gardens, but they do take up some space and there are some planning requirements around them. And they don't have to be particularly big, and for most houses this will be the right sort of size, but you can get ones which have 2 fans, although that's more likely to be for a large detached house, which I'd suggest is less likely in terms of social housing. You also need internal space for hot water storage and general gubbins. And so combi boilers, gas combis, which are popular, don't have a hot water tank. For heat pumps, you need some sort of hot water storage because the heat output, the energy output isn't generally high enough for instantaneous hot water. There are other ways to get around that, if that's an electric shower or electric taps, but you get much better efficiencies if you can use the heat pump to do your hot water for you. And so what that means is you have to have somewhere to put it. And so the traditional installation will have a hot water cylinder, that looks like a 200-litre one to me, along with the controller and general gubbins. There's circulation pumps, there's a filter down there, heat exchanger and an expansion vessel. And you can fit all of that into a cupboard about 1 metre squared, as I've done in my own house. It can be a bit tight, but you can do it. And I think as the innovation happens in the market, it will get easier. Also, an important innovation is the development of heat batteries. This is a 100% safe phase change material, basically a wax, and that replaces an entire water cylinder. They're very heavy, but they are roughly the same price as water cylinders as well, which is quite an achievement. And they can store as much energy as a water tank, but take up a lot less space. So they may be an important consideration for smaller places or space constrained homes. They've been put in blocks of apartments alongside shared ground source heat pumps. They are in practice, that's a sun amp, and other companies do exist. And the final question is the actual heating system suitable? So are the pipes and are the radiators up to scratch? For a heat pump, generally the pipe work is okay. There can be some issues with particular types of narrow pipes. although they can be replaced, of course, and often it's just the T's to the radiators. But you need to make sure that your pipe works okay and that your radiators have a high enough heat output, because heat pumps do run at less hot temperatures than boilers. So you want to run your heat pumps really at maximum 45 degrees, whereas a boiler is probably going to be set to 60 or 65 degrees, whatever the installer first put it in at. If you're interested again in that, there's the general guidance for heat pump installations from the scheme who oversee the accreditation of heat pumps in the UK, the Microgeneration Certification Scheme. And there's also a guide to emitters there, which gives you an idea of the sizing of radiators compared to existing ones and how much underfloor heating you'd need, for example. Just finally to say, before I conclude, I've got practical experience doing this. I'm a bit of a heat pump nerd. This is me next to a very large heat pump on the Isles of Scilly, which is connected to their secondary school. We also have solar panels on the roof of our terraced house in Falmouth, and there's some on the back as well. And they power about a third of the electricity that goes into my heat pump that sits just outside the garden, at the back door to the garden. And through this, I've reduced the total energy use, the total primary energy use in my house by about 82%. So you can have a staggering reduction if you do this. So just to wrap up, heat pumps are totally central to decarbonisation. That's seen around the world. And where there aren't heat networks, heat pumps need to be. And just briefly on the finance side of this will take a lot of capital. But it's important to bear in mind this is a one-off investment. So once you've made your radiators bigger and once you've got the efficiency of the buildings up to scratch and put your networks in, actually bills in the future are expected to be lower for everyone. Thank you.
Thank you so much for that, Richard. That was a great presentation and a great kick-off to this session. Next up, we've got Dan Goodchild, who will be sharing his screen in just a second. If there is, oh yeah, I see yours. That's why I haven't put my camera on this time, so we can make sure that this transition happens a bit more smoothly. So Dan Goodchild has led the carbon reduction team at Adder and Worthing councils for 2 years and is responsible for ensuring the council to meet net zero by 2030. So that's very aspirational because that's only 8 years away. So Dan, over to you.
Great, thanks for that. So yeah, as introduced, I'm Dan Goodchild. It is Ada and Worthing councils, Ada being a river in Sussex. And yeah, I'm here to talk to you today about our experience with heat pumps, which, and this is certainly not coincidence, can be summed up by the smaller the heat pump, the more we've installed. But first, so Ada and Worthing councils, for those of you that are unfamiliar, are 2 sovereign councils on the south coast of England. So that means they have 2 sets of councillors, 2 sets of budgets, but only 1 set of officers, so twice the fun for all of us. Our journey to where we are today really started in 2019 when the councils jointly declared a climate emergency, set a net zero target for our own estate and fleet of 2030, and produced our carbon neutral plan. As of last year, our total reported emissions were just under 3,000 tonnes of carbon annually. The projects I'm about to introduce were part of 2 public sector decarbonisation scheme bids that, when complete, will reduce our emissions from buildings by about 10%. And if PSDS stays around, we believe that we will meet our 2030 target. So heat pumps. We've installed 50 or so individual ground source heat pumps in 2 sheltered housing schemes. So for those of you unfamiliar, sheltered housing is social housing for anyone over the age of 55, in almost like university blocks for people with more life experience. The one here is at Tollbridge House in Shoreham, and it's a small communally heated scheme on a compact site adjacent to a conservation area. Regular maintenance undertaken by the Ada Home staff identified significant asbestos issues that we would need to overcome in order to continue running the building as a communal system, and therefore myself and my colleague Carol Murphy were asked to step in and see if we could decarbonise the scheme using an alternative system. The proposed solution has been to top up the loft insulation and then to install a shared ground loop array within the grounds of Tollbridge House. So one of the systems that Richard just mentioned. This has given each individual flat plus the communal area its own individual heat pump. It saw 7 boreholes drilled into the ground in the car park to a depth of up to 180 metres. And for consistency with the project's sister site that I'll introduce shortly, we have installed those phase change batteries, the sun amps, that Richard mentioned earlier. So that means there is now no stored hot water on site, and significantly reduces the Legionella risk that our residents may face.
Legionella.
As I said, this was funded using PSDS. However, we understand that Salix have now changed the eligibility criteria so that this would unfortunately no longer be funded. So the end result at Tollbridge House is that we have fully degassed the site, turning off our 5th largest gas boiler as a result, and resulting in an 80% reduction in carbon emissions from the building. As you can see on the right, it was quite a tight fit for the drilling rig. However, the whole building has been on heat pumps since the end of March, and with the heat pumps installed, as you can see, in some of the fortunately ample cupboard space within each flat. So a quick note on the sister project at Shadwell's Court in Lancing. This is a much larger scheme that, again, used to have a communal system, but in this case, it was a single pipe gas heating system. So this meant if any maintenance was needed in any of the flats, the entire scheme had to be shut down as the water was circulated around literally all of the flats, rather than having bypass or isolation valves installed. The hot water was also going 24/7, 365, and residents had very little control over their space heating. All of this meant that each 1-bed flat was using the equivalent of over 20,000 kilowatt hours of gas annually, far in excess of what their EPC would suggest. And I'm happy to discuss the merits, therefore, of Social Housing Decarbonisation Fund focusing on EPCs rather than actual system performance. At Shadwell's Court, we were less fortunate with the storage space. However, when these flats were built, they each had their own external coal hole. And that cupboard is now the flat's energy centre once more, as we were able to just about shoehorn the heat pump at the bottom and the sun amp at the top into it. This project, being 41 plus 1 heat pumps, has unsurprisingly taken longer, but has represented our largest gas boiler, with the exception of our main office building that we've been able to degas. We are often asked what our key lessons learned from this project. So in no particular order, here they are. We've learned that radiators appear to be a normal size and are warm to the touch. In this instance, all we've done is basically made single panel emitters double panel. And aside from a couple of awkwardly sized emitters under windowsills, there's been minimal making good requirement needed. For ground source heat pumps, we found that prevention of damage is significantly better than repair. We had soft ground for much of the 3, 4, 5 month drilling period. So where we had put down track matting, it was much less damaged and re-established much easier, with no need for reseeding. This saved the contractor money, but also gave us significantly less complaints from residents and from neighbours. Unsurprisingly, engagement is key. These are sheltered housing units, so the residents do tend to have a lot of time on their hands. However, regardless of who you're doing this to or with, you need a good site manager and/or resident liaison officer who has a good knowledge of the project and isn't afraid to spend a lot of their time door knocking to give at least 24 hours and ideally a week's notice of works being done. And finally, it's often said that industry isn't up to scratch at the moment. On one of the 2 sites, the subcontractor we had installing the plumbing works had never installed Kenza heat pumps before. In fact, the team doing the work may well have not installed any heat pumps of this kind before. However, the plumbing was essentially identical, and all it required to upskill the entire team was a day's training on purging and commissioning the system. And I would now not hesitate to use them on another heat pump project. So on to something slightly bigger. This is the Shoreham Centre where I'm currently sitting. It is the democratic home of Ada District Council, and as well as also housing a number of community and voluntary sector organisations and some of our own staff. It's the single largest emitter of carbon emissions within ADA's corporate assets and has been built in 3 stages in its life, with separate heating systems for each one. In the same PSTS bid, we applied to install a bank of air source heat pump units in the car park. This was PSTS phase 1, so partly given the desire of the council's estates team to minimise disruption to the building users, and the fact that maintenance had always been reasonably good on the site, we took a pragmatic approach to install a bivalent system and have replaced the oldest gas boilers. In other words, both of the projects here today, we don't believe would be eligible for this forthcoming round of PSTS. We have had external design support for this project, which has been an interesting experience in itself. We've eventually agreed on a solution to install weather compensation and BMS upgrades, as well as the new plant, which acts as a parallel bivalent system. This means the new system will run predominantly off air source heat pumps, with the gas boilers only firing when external temperatures fall below a certain point. The funding has also allowed us to install more heat pumps than necessary for the current setup, so that when the opportunity arises to permanently lower flow temperatures of the systems, we can swap out the emitters and not have to finance or fund any additional heat pumps. So on the slide you can see at the moment, the bottom photo shows one of the biggest costs for this project, which was the installation of a brand new substation in the car park. This has allowed us to install heat pumps that will serve all 3 plant rooms from the same bank, including when the eventual removal of the gas boilers takes place. The heat pumps arrived yesterday, and we've left space on the plinth for additional capacity should we ever need it within the building. Overall, most of the work so far has been external or in wide common areas or plant rooms, so there's been very minimal impact on the building occupants, although the cafe is due to shut for a week whilst the plant room serving it is reconfigured. Additionally, obviously, the building's electrical demand will significantly increase as a result of this, and so we are now looking at an investor-safe business case for PV for the site. And finally, I couldn't finish without mentioning a big heat pump, but we'll keep it brief as there's a half-an-hour presentation that sits behind this one slide. So alongside the council's own 2030 target for its own estate, they also set a wider 2045 target for the whole area to be net zero. The chart on the right, it's a bit small, but essentially shows that 2% of UK's emissions come from heating public sector buildings. And in Worthing, we're trying to use that 2% to develop the cheapest way of decarbonising the rest of that pink band, the homes and commercial sectors, by not only the council, but the NHS and some schools committing to be anchor tenants of a very low carbon heat network, which can then provide low carbon heat at a reasonable cost to any other existing or new buildings within Worthing. We're doing this by developing a district heat network to serve 27 public sector and new build residential buildings within the town. The primary focus of the heat network has always been decarbonisation. We have never compared this to gas systems, except for the amount of carbon we could save. And so the primary proposed heat source for this heat network is a 3 megawatt, so 1,000 times bigger than the original Kenza ones we showed earlier in the programme. Sewer source heat pump, so it's an in-sewer system rather than being located at a wastewater treatment works. Thanks in part to funding from the what was the Greater South East Energy Hub, we've got 12 months of monitoring data from the sewer, and so are confident that we could meet over 80% of the heat network demand from the sewer already, with additional heat able to be abstracted from the sewer if the demand is there. We received HNIP funding last year and are currently in the middle of a very long procurement process, with partner organisations hopefully appointed to deliver the heat network by March next year, and heat on being the following year in 2024. That's it from me, so thank you.
Thanks, Dan, for that presentation. Loads of great insight there and lessons learned that you've shared there. So I hope that the delegates today have learned something new. But we're moving on to the Q&A. So we've got Dan, Richard, if you can take yourself mute and put your camera on. And we'll also be joined by John Taylor, who's from the Greater South East Net Zero Hub, to provide some insights. And the chair for today is going to be my colleague, Mike Mosley. Mike, would you like to take over?
Good afternoon, everyone. Is it afternoon? I've lost the time. There's some interesting questions coming in, so I'll just sort of rattle on through